In this video, I will teach you how to use average rate of change to estimate an unknown value of a function. This is AP Precalculus Topic 1.2. If you appreciate this content, please give it a like. In Algebra 1, you learned that a linear function can be written in slope-intercept form y equals mx plus b, where m is the slope of the line and b is the y-intercept. In higher level math, we prefer to use point-slope form. Y minus y1 is equal to m times x minus x1, where m is the slope of the line and x1 comma y1 is a point on the line. Example 1. Write the equation of the line with slope negative 1.57 and passing through the point 21, 37. Using point-slope form, we write y minus y1. So in this case, that's going to be y minus 37. And then that's going to be equal to the slope, which is negative 1.57, times x minus x1. So x minus 21. And that's it. This is an equation of the line with this slope passing through this point. The following examples are all calculator active, starting with example 2. F at 3 is equal to 17, and f at 10 is equal to 11. Part 1. Find the average rate of change of f of x on the interval from 3 to 10. Write your answer as a decimal approximation. The average rate of change on the interval from a to b is given by f at b minus f at a over b minus a. So the average rate of change of f on the interval from 3 to 10 will be given by f at 10 minus f at 3 over 10 minus 3. We are given that f at 10 is 11 and f at 3 is 17. (11 minus 17 is negative 6, and 10 minus 3 is 7. They said to write our answer as a decimal approximation, so I'm going to go ahead and also write the decimal form. To 3 decimal places, the average rate of change is negative 0.857. Let's store all of the decimals into a letter on this calculator for later use. Let's use letter R for rate. You can just hit the store button and then alpha and pick letter R and hit enter. So if we need this value later, we can just use the letter R to capture all of the decimals so we don't have a rounding error. Negative 0.857. And let's go ahead and define this as R so we can use this in our calculations. Part 2. Use the average rate of change found in Part 1 to write the equation of the secant line on the interval from 3 to 10. Quick side lesson. A secant line is a line passing through 2 points on a function. So the secant line on the interval from 3 to 10 would be the line passing through these 2 points. We are about to write the equation of a secant line like this. We like to use point-slope form to write a linear equation, so we're going to need a point and the slope. We can get a point by using one of the values given in the setup, and the slope will be the average rate of change. You don't have to show this part, so I'm putting it in a thought bubble. I'm just showing it for instructional purposes. So according to point-slope form, the equation will be y minus y, so that's y minus 17, is equal to the slope, and we can just write R since we already defined it, times x minus x, so x minus 3. And that's it. This is the equation of the secant line on the interval from 3 to 10. When you are given the context surrounding a function, you can use the equation of a secant line to approximate an unknown value of the function. Example 3. A developer begins building houses in a large neighborhood. After 1 month, t equals 1, the developer had built 6 houses, At the end of month 8, t equals 8, the developer had built 15 total houses. The number of houses that have been built by the developer after t months can be modeled by the function h, given by h of t equals a times b to the t plus 1 power, where h of t is the total number of houses built at time t months. Part 1. Use the given data to find the average rate of change in the number of houses that have been built in houses per month from t equals 1 to t equals 8 months. Express your answer as a decimal approximation. Show the computations that lead to your answer. The average rate of change of h of t on the interval from 1 to 8 will be h at 8 minus h at 1 over 8 minus 1. H at 8 is 15. And h at 1 is 6. The average rate of change is 9 over 7, but let's go ahead and write this as a decimal approximation. 3 decimal places, 1.285 if you truncate, or 1.286 if you round. Either answer will get you full credit as long as you include the units. H is the number of houses built, and the time is in months. So we should add the units houses per month. And let's define a variable r for rate that is equal to this rate of change. For this particular problem, r is a very simple number. It's just 9 over 7. But I want us to practice storing values into the calculator for later use. We can store this value into letter r by hitting store and then alpha r. Enter. Part 2. Use the average rate of change found in Part 1 to estimate the number of houses built at time t equals 12 months. Show the computations that lead to your answer. When they say use the average rate of change to estimate some value, they want you to find the equation of the secant line and use that equation to estimate the value. To write the equation of the secant line, we will use point-slope form. So we're going to need a point and the slope. For a point, we can use one of the input-output pairs given to us in the setup. For example, at month 1, t equals 1, the developer had built 6 houses. So we have the point 1, 6. We equally could have used the point 8, 15, and that would give us the same answer. For the slope, we will always use the average rate of change, which we have defined as r. So I'm just going to use letter r in my calculations. This is point-slope form, but we need to be careful to use the variables provided for us in the setup. So instead of y, we will use h. And instead of x, we will use t. And of course the slope will be the rate, r. For the equation of the secant line, y minus y becomes h minus 6 is equal to the slope, which is the rate of change r, and x minus x becomes t minus 1. This is the equation of the secant line, but to use it to estimate the value of a function, we need to get h by itself. So I'm just going to add 6 to both sides, and we get h is equal to r times t minus 1 plus 6. Let's switch to function notation and write h of t instead of just h. Also, this secant line equation is an approximation, so let's use this wavy equal sign that means approximately. Now let's estimate the number of houses built at time t equals 12 months. In other words, let's find h at 12. H at 12 will be approximately equal to r times 12 minus 1 plus 6. Let's type this expression into the calculator. Obviously, you can just type 11 instead of 12 minus 1, but I'm going to type it in just like this. To pull up the r, we hit alpha r, and then we can write 12 minus 1, or you could put 11, and then plus 6. So there's your answer, 20.142 if you truncate, or 20.143 if you round. So that's the final answer for part 2. By the way, I wanted to show you how you could define the value of a letter and then use that letter in your calculations. And I wanted to show you how to store a value on your calculator into a letter. However, you don't have to do that. If you wanted to use 9 over 7 in your calculations instead of r, that would be fine. Just be careful. If you use 9 over 7 on your calculator, you might get a fraction for the answer, and they really want you to use a decimal approximation. So you would have to go back and hit Math, and then Decimal, and this will switch your answer to decimal form. Let's do a couple more examples. By the way, on the AP exam, FRQ number 2 Part B will look just like these problems that we are practicing. Example 4. In May 2011, t equals 0, 65% of US adults did not own a smartphone. In November 2016, t equals 5.5, only 23% of US adults did not own a smartphone. The percent of US adults that did not own a smartphone can be modeled by the function s, given by s of t equals a plus b natural log t plus 1, where s of t is the percent of US adults that did not own a smartphone t years since May 2011. Part 1. Use the data to find the average rate of change in the percent of US adults that did not own a smartphone in percent per year from t equals 0 to t equals 5.5 years. Express your answer as a decimal approximation. Show the computations that lead to your answer. I encourage you to pause the video and try to do this problem on your own, and then play the video and see how you did. The average rate of change of s on the interval from 0 to 5.5 will be given by this expression. S at 5.5 is 65, and s at 0 is 23. So now we have this. Let's put this expression into the calculator to get a decimal approximation. Make sure you know how to make a proper vertical fraction on your calculator. My software is a little dated, so I have to hit alpha y equals enter to make it happen. On your calculator, that will also work, but you might be able to use a shortcut where you hit alpha and then x, and that might make the fraction immediately. Try it out. The average rate of change is negative 7.636. Always use 3 decimal places. Let's define this value as r. And let's go ahead and store this value as r in the calculator. So hit the store button and then alpha r. Wait, I forgot the units. That's better, percent per year. Part 2. Use the average rate of change found in Part 1 to estimate the percent of US adults that did not own a smartphone for t equals 10.2 years. Show the computations that lead to your answer. Let's write the equation of the secant line from 0 to 5.5 and then use that secant line to estimate the value of this function. Because we are using point-slope form, we need a point and the slope. For the point, we can use one of the input-output pairs provided to us in the setup. Let's use 0, 65. The slope will always be the average rate of change, which we have defined as letter r. Point-slope form looks like this, but we will use the variables provided to us in the problem. So instead of y, I'm going to write s of t. So y minus y becomes s of t minus 65. is equal to the slope, which is r, and x minus x will become t minus 0. Let's get s of t by itself by adding 65 to both sides. Dropping the 0, we get s of t is approximately equal to r times t plus 65. Now let's estimate the percentage of US adults that did not own a smartphone for t equals 10.2. In other words, let's approximate s at 10.2. This will be approximately equal to r times 10.2 plus 65. Let's put this into the calculator. Let's do alpha r times 10.2 plus 65. And that's it, negative 12.890 if you truncate, or negative 12.891 if you round. So here's your final answer. By the way, I'm not sure if a negative percentage in the context of the problem makes sense. When you're talking about people, how can you have negative percent? But let's just ignore that for now. Here's one more example for you. Please pause the video and try to work out this whole problem by yourself. Then hit play and see how you did. Example 5. In 1970, the College Board began offering separate AP exams for AP Calculus AB and AP Calculus BC. In that year, t equals 0, a total of 14,379 AP Calculus exams were administered. In 1983, t equals 13, a total of 35,489 AP Calculus exams were administered. The total number of AP Calculus exams administered in a given year can be modeled by the function e, given by e of t equals a times b to the t power, where e of t is the total number of AP Calculus exams administered in year t, and t is the number of years since 1970. Part 1. Use the given data to find the average rate of change in the number of AP Calculus exams administered in exams per year from t equals 0 to t equals 13 years. Express your answer as a decimal approximation. Show the computations that lead to your answer. This time let's define the letter r as being equal to the average rate of change right from the beginning. On the interval from 0 to 13, the average rate of change of e will be given by this expression. In the setup, we were given the values of e at 13 and e at 0. So now we have this. Let's just put this into the calculator to make the decimal approximation. Uh-oh, we got a fraction. Let's convert this into a decimal by hitting Math and then choosing option 2. So here we go, 1,623.846. Don't forget the units, which are exams per year. Part 2. Use the average rate of change found in Part 1 to estimate the number of AP Calculus exams administered in 1994. T equals 24 years. Show the computations that lead to your answer. When they ask us to use the rate of change to estimate a value, they mean write an equation for the secant line from 0 to 13 and use that to estimate the value. To write the equation of the secant line, we will need a point and the slope. For the point, we can use the input-output pair 0, 14,379, and the slope will be the average rate of change. Point-slope form looks like this, but we need to use the variables given to us in the setup. So instead of y, we will write e of t. So y minus y1 becomes e of t minus 14,379. And then the slope is r. And x minus x1 becomes t minus 0. To use this secant line equation to estimate a value, we need to get E of t by itself. So let's add 14,379 to both sides. This is an approximation, so instead of an equal sign, let's put the wavy approximately sign. And we can drop the 0 now. So I'm just going to write RT. R times t plus 14,379. Now we can estimate the number of exams administered in 1994. In other words, we can approximate E at 24, which will be approximately equal to R times 24 plus 14,379. Let's type this into the calculator. I forgot to store the rate of change into a letter on the calculator. Let's do that now. Store alpha R. Now it's in there. So we were doing R times 24. So this is going to be alpha R times 24 plus, what was it? 14,379. 14,379. Kabam! 53,351.307 if you truncate, or 0.308 if you round. And that's it for example 5. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.